Okay.
Perfect. Okay. Well, welcome back, students. We have a very, very special guest, Mr. Taya Von Windheim. She's a PhD, a postdoctoral scholar in the medical modeling and materials and manufacturing, the M4 lab at The Ohio State University. Sort of pains me to say that because I went to Michigan, but I love her expertise. I do love that she came to participate. And more importantly, Mr. Taya, she works in how 3D printing can enable new medical solutions. So we're gonna learn a lot about materials science and 3D printing. So please, without further ado, Ms. Taya Von Windheim.
Thank you for the warm introduction. Yeah, you'd be happy to hear that the surgeon I work with is actually from Michigan. So our lab is a nice collaboration between Ohio State and Michigan, and I'm actually from North Carolina. So as long as you're not a UNC fan, then it's all good. But yeah, as you could tell from my introduction, my expertise is in material science and specifically 3D printing in medicine. I'm going to be talking just about 3D printing kind of in general today, but yeah, that's what we'll be talking about. I'm going to, my computer's a little slow, so I think I'm pressing forward, but it's not moving. Oh, there we go. I'm going to start off by giving a bit of a background to material science and myself. Then I'll talk about different types of 3D printing technologies. We'll do a little bit of an activity on using 3D printing technologies, and then talk a little bit more about the end of applications for 3D printing. So I get this question a lot. What is material science and engineering, or what does a material scientist do? So material science is all about understanding different materials that are around us and characterizing them. So this is a common diagram here to the left. Can you guys see my pointer? Or I think I can also maybe use a laser pointer. Maybe not. But can you see my mouse if I move it around? Oh, and also too, I meant to mention when I start, if you do have questions throughout, feel free to ask. We'll definitely have some time for questions at the end as well too. But if questions come up as we go along, feel free to ask. So the basis of material science is a characterization and understanding different materials. And the way that material scientists talk about it is kind of this bottom triangle here, understanding the structure, the processing, and the properties of different materials. And all of those components incorporate or are brought together to evaluate the performance of different materials. So as you know, as you interact with on an everyday basis, there's lots of different types of materials. There's metals, there's polymers or plastics, ceramic materials, biomaterials, and then composites, which can kind of be a combination of those different classes of materials. And to help kind of understand what the processing structure and properties relationship looks like, or why material scientists focus on that, I have an example over here of two things that are made out of aluminum. One of them is a chair, and the other one is an aluminum foil roll. So they're made out of the same material, but they have very different properties, and all of that is linked to what their structure is and how they're processed. So even if you were to look on the atomic organization of these materials, even though they're both aluminum, that would be different. They're also made using different processing methods. So this has to be a really thin, flexible material. Well, you want the chair to be really strong and rigid. So typically this is welded together of larger components while this is rolled out so it's nice and flat. And so those are different processing methods. And that ends up meaning that the material has different properties and it performs differently. So you want the chair to be nice and strong and sturdy. The aluminum foil also still needs to have some strength to it so it doesn't tear super easily, but enough flexibility that it can be wrapped around things and crumpled up or different things for those applications. So that's kind of what it means to be a material scientist, is to look at the how something has a different structure and how you need to process it to get different properties and characterizing materials. And there's also, that's a really important part of developing new materials. And so also too, just for a little bit of, if you're interested in maybe being a material scientist or more about what a job in industry and industry's material scientists work in, it could be really lots of different types of jobs, from more on the technical side of actually designing and characterizing products, being a designer materials engineer, a metallurgist works specifically on metals. There's also lots of opportunities in science to do research on developing new or characterizing new materials, or more in the business side of being a technical sales engineer. And kind of as you make or can tell from your daily life of interacting with materials, there's really a wide range of industries that then material scientists work in, just because of the broadness of the field and how it looks at those specific characteristics of materials, but it's agnostic to all different types of materials. So you really can work in all sorts of different types of industries as a material scientist, and on all sorts of different types of applications. So just a little bit more about myself too. I've mainly always worked in academia or startup companies. So so far been in school for basically my whole adult career. I started at NC State. So like I said before, I'm from North Carolina. I started at NC State University. Some other things I worked on when I was there doing my bachelor's in material science. I worked with the Entrepreneurship Initiative. I did some research on environmentally friendly materials, and did that one part. There's a research experience for undergraduates, which is a national program, which is available at undergraduate institutions across the US. And then I also took a year, kind of an untraditional spot to take a gap year, but between my junior and senior year, I did an internship and studied abroad. So instead of working on my course curriculum, I just didn't enroll in classes and worked at a startup company, and then did study abroad for the other semester. And then it was not until I went to Duke for my graduate work that I started working more on the medical device side. So I was still working on material science by characterizing 3D printed materials, but it was for applications in medical devices. There I also did a tech transfer fellowship about evaluating technologies that come out of universities, and I collaborated with a medical device startup that came out of Duke. And then last year, I started my postdoc at Ohio State, basically just additional training after doing a PhD or another sort of doctoral degree. And I was really interested in taking on this position because I wanted to learn about the actual impact of 3D printing medical devices. So working in a hospital, working with a surgeon, and actually serving real patients. What does that look like? So right now I'm look a lot at evaluating patient-specific medical devices and what sort of 3D printing technologies make sense to have in hospitals, as well as working with a lot of other industry collaborations. And while I've been in academia so far, I think after my postdoc, it's a temporary position, I'll probably go work in industry or maybe some other nonprofit related to medical devices. So go out of academia into the startup sector. But just wanted to give you a little bit background about me and what it means to be a material scientist. So now getting into the cool part of it with 3D printing. I'm going to start off talking about why anybody would even want to use 3D printing compared to other processing techniques. One of the main reasons is because you can easily produce these complex structures. So here are two examples of atypical organic shapes that are difficult to manufacture using any other sort of traditional processing method. Another reason is because it's very economic to do low volume production. So traditional manufacturing has a high startup cost to use it, and then you can get it to be very low over time, but you need to have a high volume. With 3D printing, that cost per part stays pretty consistent over time. And so this is why 3D printing is typically used in rapid prototyping to test out new devices. It's also why it's easy for us to make patient-specific or personalized devices, because it's not too expensive to make that very specific personalized device, and even though you're not manufacturing it at a high volume. Another reason is because 3D printing is a very mobile manufacturing method, and it can be printed on location. So that's one reason why we can have manufacturing inside the hospital, is because 3D printers are much smaller than some of traditional manufacturing methods. Another reason is that you can use 3D printing technology to make multi-material parts. So this example in this picture here, it's a rigid material on the top and bottom, and then in between that, it's a flexible material. You can also make different colors then, because it's multi-material, or other material properties can also be modified in the multi-material by using the multi-material technologies. And then another, I'm not going to say final benefit. I think there's lots of ways that 3D printing can be used advantageously, and people are just becoming more creative and more creative with the uses as the technology is more widely adopted. But this is an example here of a device that is 3D printed as one part, even though it's actually an assembly of parts. So you can see here in this video, after it loads, that if this was made with traditional manufacturing, all of these components would have to be produced separately, and then you would have to assemble them together. But this is just one part that's printed, and the tolerances are proper so that you can actually use it functionally. So this is the next slide. Sorry, this slide is a little overwhelming, but it's a very comprehensive overview of all the different types of 3D printing methods and technologies. But really what I want to focus on here is you look, I think it's about like the 4th level down, where it shows the different types of materials. And this kind of goes back to the beginning when I was talking about processing and properties in different materials. Just because you have a certain material, you can't process it in every way, or you need to have specific types of processing for it. And so 3D printing, there's a lot of different techniques that enable you to print with different materials. And then each of them kind of has their pluses and minuses, but it's important that the processing method matches the material, and then that actually matches what you're trying to design for and what outcomes you want to have with your part and the final performance and properties of that part. I am going to go over some of the methods, or just give you a brief introduction for how they work. I'm going to break it up by the different types of materials. So we're going to start off with plastics. And has anybody seen or used a 3D printer before? And if you did it look like this one here? Basically, you melt the plastic at the top, and it's the hot ends on an axis that moves around and kind of then extrudes the materials, kind of like a hot glue gun. Or maybe nobody, or yeah, so if anybody's seen a 3D printer, can you maybe put something? Yeah, okay, I see in the chat now. Yeah, so this is kind of the most common, most accessible, cheapest form of 3D printing. And it's called material extrusion, or lots of other names too. You'll see that, or it's common in 3D printing that as the field develops, that there's lots of different acronyms and names for things that are similar. There's a couple different other types of ways to 3D print plastics. So this one, you actually start with a liquid plastic, and then a laser or some sort of light source at the bottom bakes the material solid through curing it. And you can get some pretty cool complex parts from that. You also get a bit of a higher resolution than the material extrusion I was showing previously. Then there's also this powder-based method here on the right, where a laser goes around and selectively melts the polymer in certain areas inside the powder bed. So at the end, you have your solid part in this whole bed of powder. And that process is also a little bit more accurate than the original material extrusion method I was showing you on the previous slide. But it's not just plastics that you can 3D print. There's also ceramics. I have another video here showing you some concrete 3D printing. Nice soothing music, but they talk a little bit in a second.
The company can set up the 3D house printer at a build site in 6 to 8 hours and can print a 1900 square foot home in under 48 hours. The printer lays concrete layer by layer, creating the foundation and the interior and exterior walls of the house.
So that's a method that's used to then make, well, in this example, making houses, which is typical for the concrete printer, but that's not the only application for use. Let's go to the next slide on metal 3D printing.
Complicated hollow structures are now possible, allowing designers to integrate cooling ducts directly into parts, an incredibly useful tool for high temperature parts like turbine blades and rocket nozzles. We can perform something called topology optimization, where we use finite element analysis, a type of stress simulation, to tell us exactly where material is needed, allowing us to generate the perfect structure for our application, similar to how hollow bones are formed, and thus allowing us to save on weight, helping lightweight vehicles to gain even more performance. Often, parts are machined down from giant blocks of raw material to their final form. In aviation, we measure this waste with the buy-to-fly ratio, which divides the weight of the final part by the weight of the raw material it was manufactured from. Imagine taking a material like titanium alloy, which can cost upwards of $30 per kilo, and then throwing away 90% of it in the manufacturing process. Needless to say, this is a massive source of increased costs that 3D printing could help reduce. All of these benefits can come together to unshackle engineers to form the perfectly shaped objects, and perhaps one of the most interesting applications of this is this incredible 3D printed Aerospike rocket engine that has incorporated liquid cooling channels directly into the rocket nozzle's interior and shaped everything optimally to provide a highly efficient rocket nozzle that can operate efficiently at many different altitudes. But even with all these amazing applications, we rarely see 3D printed parts outside of prototyping applications like this. It's clear that 3D printing can take human manufacturing to its next evolution.
Okay, so there's a little bit on metal 3D printing. And I think the next slide is the, so now we're gonna do a little exercise and activity. Do you guys have any questions about 3D printing, kind of just the overview of how it works and different materials before we do the activity? Feel free to just jump in if you do.
So guys, you can also put your questions in the chat, and I can be looking at the chat as well. I believe Jay said, yes, I've seen one in use and it looks exactly like this. So.
Yeah, that was the common material extrusion 3D printer. But now we're just gonna do a quick activity about using 3D printing technology. It's pretty broad, so I know you guys are doing a lot of innovation and creative thinking this week, so I hope you're ready for more of it. Basically, thinking about the benefits of 3D printing and products that you use or are familiar with from your daily life, create a new 3D printed version of the product. I did list some of the benefits I talked about earlier here on the right. And they talked a little bit about some in the videos as well. But maybe if we just take 5-10 minutes and did some brainstorming on using 3D printing, and then also let me go Oh, so somebody from the Rees family I see in the chat asked the question of, can you 3D print silicone? That's a really good question. So I'm gonna try not to, I feel like it's a question I would like an answer to. It's not one that I use regularly in the materials that I've been 3D printing. And something I struggle with it for people that say that they can 3D print silicone is that the processing that you use to typically create silicone, you usually just heat it up, or you just let it, you have very liquid material that you put together and it will solidify over time, is not really compatible with 3D printing. So if you just have the liquid version of it, it has to be able to have some structure while it prints, to then be able to print easily. And a lot of the polymer ones, they use laser or light source to 3D print. But you can print materials that are really similar to silicone. So I'm probably getting too technical for that. But you can print materials that are like soft and elastic, but they tend to not be as strong as silicone. So that's one challenge. And actually, typically in my lab, I'll show some examples later, but if we want to use a silicone-like material, we'll actually 3D print molds for it to make the custom geometry that we want. And then just mold silicone typically. And that's how we have the most success for the applications we need. But if you want something that just kind of has that soft feel, and you're not too worried about it being as strong as silicone typically is, then there are materials that are similar to silicone that you can 3D print. Sorry for getting a little bit too much into it to start.
That's great. Dr. Natalia, I believe that they're asking because we discovered this morning that silicone is what's being used for solar paneling. So their inventions include some type of solar panel for this week. And so the combination of the 3D printer and the solar panel will be amazing. So yes.
Oh yeah, that's a good, I'll actually maybe do some quick searching to see if I can find something specifically if they've been doing some 3D printing for silicone in solar panels. So yeah, not the rubbery soft material, but the ceramic type that then is used in that. I think you could find some stuff out there. So yes, sorry. I use silicone a lot in my lab, so that's where my brain went to initially. But yeah, so feel free if there's something related to your projects that you're working on that you think, I think 3D printing in general helps a lot with prototyping. I also want to send the link to kind of there's a really good website. I didn't mean, well, I'll bring the screen back up. I'm just going to put it in the chat. The guide to 3D printing. It's where I got the initial graphic from. So this will bring you to a website. And I think you have to go into one of the tabs to get the overall graphic that I showed with all the different types of 3D printing methods. But it's also just a good guide overall of what 3D printing is, how it works, what are the benefits. So let me go back to the presentation here.
Mr. Taya, I have a question for you. Like, what's like the most unique thing that you've seen has been 3D printed or attempted to be 3D printed?
Mm-hmm. I mean, so I'll show a little bit later on some of the bioprinting stuff. I think that's crazy. So I think for the medical device and like healthcare space, they're not quite there yet, and there's a lot of challenges to getting there. But I think, you know, eventually we will be 3D printing organs and those sorts of things in some sort of way. And yeah, typically the 3D printing's used to give it structure, to get that complex structure to help guide the cellular components of it. But just a fun thing that I like from one of our demos, or just like we have like look touch field tables with lots of demo parts on them at Ohio State. And on the metal side, they 3D printed a hollow ball out of titanium, and it actually bounces. So you never think of like metals they're just heavy and strong and stiff, but kind of just shows how you can use the complexity that you're able to create with 3D printing and totally transform how materials are used. So that's just one of my like favorite fun demo parts is the bounceable metal ball. I don't know if we just want to take a couple more minutes. I was going to try to think of one myself too, but with all the talking. So.
Well, I'm a designer, and I was wondering if jewelry could be made using the 3D printer.
Yeah, definitely. It sometimes for like the molds for it, that's also really common if you want to kind of more economic to do it that way than to directly 3D print it out of metal to make a wax mold or some sort. I don't know the details exactly how, but then they'll cast a metal in it by melting it, like using a low melting temperature metal, or then even just directly doing it out of plastics. I've seen as well. One of our printers, when we were doing some trial runs out of it, I found a CAD file online of some earrings. So I made those on one of our plastic 3D printers.
Wow. Thank you.
So maybe what time is it now? Maybe take just another, maybe at 11:20, 4 minutes, and then if anybody has ideas.
Okay, that works.
Share them.
So guys, be thinking, on your own, what could you possibly do with 3D printing, or how could you make a mark in terms of 3D printing? And then we'll share out here in 3 minutes. All right, guys, I know it's right around 11:20. Would anyone like to come on the mic and talk about how they might incorporate 3D printing with their invention or creation or anything of that nature? Definitely don't be shy.
Jace, you're on mute. I'm not sure if you're trying to talk. It showed that it like showed up level or yellow around your.
Oh, yeah, I definitely was. I'm sorry. I thought it was talking. You said the question. You said sharing ideas, right? We're sharing ideas. I thought of a way how to make a 3D printed solar panel. We could build like the frame of the solar panel, and then put all the parts that we need to make the solar panel run and things on top of the plastic frame. And we could place the plastic frames on whatever we need, like a house or a power bank or something like that, you know?
Nice idea. Nice idea. Definitely solar panels. You know, we were just talking about it and sort of infusing all of our components of this morning. Great. Anyone else out there? Good idea with 3D printing. Any ideas? I know you got some wonderful creative minds. Don't be shy.
I was gonna use the 3D printer to make like a protective barrier around the casing of my object, so it doesn't fall, like just in case it falls.
Nice, nice. So like using those components. Also, Daniel, like when talking about the hat, the solar power hat that you saw earlier, could you have any ideas maybe about that, or maybe wearable, anything that comes to mind?
Not really. I don't. Maybe I can put like a 3D like barrier around the hat, or like the brim of it where it's supposed to be where it's supposed to be charging the phone. Maybe I can put like a protective barrier around that so it doesn't get damaged.
Yeah, man. See, we're putting it all together. Excellent. All right, I see a hand from one of our other ambassadors, Dr. Nick Williams. Sir, please share.
So given the sort of, I think everyone can hear me. Given the recent developments with the James Webb Telescope and the recent interest in space exploration, I think that launching rockets, a significant issue with that is weight. And if we want extended space missions, it'll be challenging to predict everything that's needed on those 6-month to 5-year trips. Is there a way that we could sort of leverage moon dust to be able to, we just pack, glue or something, and we can mix that with space dust, moon dust, to be able to make complex shapes, like say a wrench or a tool or a house on space, and not have to actually pack up all those materials, which will cost extra billions upon billions of dollars. You just bring up the raw materials and print whatever you need. So I guess this is less of an actual specific development, but more of just a general broad use. Maybe this would be a new 3D printer as opposed to a new 3D printed object.
Say, Dr. Nick, that almost reminds me of that phrase, like, building the ship as we go, or building the plane as we go. It sort of opens your eyes of, uncharted territories of what can we use 3D printing for to help save costs, be more efficient, and also learn while we go. Excellent, excellent, excellent.
Exactly,
yeah. Anyone else before we conclude here in a few minutes? Great ideas, great thought process. We had some solar panel ideas, had some wearable ideas, moon ideas.
I actually have a question, and then I'll share. Yeah, is fabric printable, like 3D printable? I don't think so.
Yeah, it is. I mean, I think you could definitely print like sheets of things that are pretty thin, that could be almost like fabric. And then there is, I forget what the right way to be like to look it up, but if you for shoes, I feel like it's like the Nike Flyknits or something like that. And it's not really 3D printing, but basically the way that they weave the patterns, it's in custom designs that they're not then cutting material out of the patterns. They're basically directly weaving the threads into the pattern that they need for the shoe. And it really cuts down on the waste in the fabric and textile industry. So kind of like what I was getting to when I was talking about all the different types of 3D printing. Really depends on what your starting material is and what you ultimately want to create what is depends, or the material that you, or the technology that you use depends a lot on that. So I don't think it would really be covered in the chart I showed earlier, but there's definitely people doing things
Right.
like that.
So if I wanted to make a gown, could I 3D print all the materials for it?
Yeah, definitely. Your own personalized gown. Yeah.
Okay. So yeah, so that was my question. I'll share. So I thought maybe like metals you can 3D print. So I thought about 3D printing a barrier like a metal for the phone case that goes against the actual phone. So when you put it in the sun, it doesn't fry the phone, while still with the panel still being able to charge it.
Oh, cool. Yeah. Yeah, I think there's a lot of parts of 3D printing that could help with that.
Yeah, very cool. Very cool. Very cool.
Yeah, I do have a couple additional slides then just showing some different applications of 3D printing then and some products that have been made with that. So maybe I'll go ahead and move on to that, and then we might, hopefully you'll have like a couple minutes at the end still just for some open questions.
Okay, great.
All right. So of course, there we go. Oh, okay, one more video. Gotta be patient with it.
What do NASA, McLaren, and the restaurant Sushi Singularity have in common? They have all incorporated 3D printing or additive manufacturing into their work in some form or another. 3D printing is bringing many changes to a number of important industries. Companies have begun printing everything from fully functioning cars to Michelin-starred dinners. Medical research institutions have even experimented with printing functioning body parts, paralleling some of our favorite science fiction shows. Recently, additive manufacturing showcased its practical versatility, becoming a powerful tool in tackling some of the unprecedented challenges posed by COVID-19, helping to supply health workers with personal protective equipment and patients with ventilators. So is the 3D printing revolution here to stay, or is it merely a trend? For the uninitiated, 3D printing is the process of making.
Yeah, so that just shows a little bit more about the breadth of different applications that 3D printing is used in. And then I just wanted to talk a little bit about how we're using it inside the hospital at Ohio State. So the first part is for surgical planning. This is what we do kind of most commonly and consistently. Here's a surgeon in the OR. The surgeon's a head and neck reconstruction surgeon. And during the reconstructions, when they have to reconstruct bony anatomy, they need to use titanium plates in order to hold everything in place. And here he has a 3D printed model of the actual patient's anatomy in his hand, and he is bending a metal plate around it to then match the anatomy. So that makes the process a lot faster than for him, instead of having to try and work in the surgical area around a patient's anatomy that they're operating on and trying to get access to certain parts. He actually has the whole bony anatomy, the mandible part of the jaw in his hand. Another way we use it is just for visualization. So this is a tumor in a tongue. We can 3D print this. This is the CAD version of it here. But basically, so the surgeon can see in 3D where the tumor is, and then the yellow part's the margin around the tumor. And then another common thing that we do are creating models for training and simulation. So as I was talking about the silicone earlier, this doctor and a trainee are working on a simulator of a complex airway anatomy. And while the most interesting part of it is actually the internal structure of it, which you can't really see from this picture, we're able to kind of create a mold with that for the silicone. And then there's a called a tracheotomy, a hole in it, and they're practicing basically how to intubate a patient when they have this tracheotomy. And this is much cheaper than trying to buy models from other sources, just being able to make it with the silicone and the molding in-house. And it enabled us to make slight modifications and really make a huge difference for the trainees. Just again, an emphasis on all the different types of ways that 3D printing is used. These are some other polymer parts that are plastic parts that are made with 3D printing. So the top left are some dentures, again, customized, personalized. The bottom left are actually just tennis shoes that I think you can buy them. They're from Adidas. I forget the specific name of them, but you have this complex cushion part on the bottom that's 3D printed. Sometimes just for aesthetic reasons, sometimes, it's a new feel for the running shoes, but here they're also with the razor, just kind of like an aesthetic, cool 3D printed handle. Some other things, a hearing aid implant hearing aid that's then customized to the patient. Also Invisalign, that's probably like the broadest adopted, longest, like original 3D printed device. So I think initially they were just 3D printing molds for then forming plastic around them, but now I think they actually 3D print directly the aligners. And then the last one here is a football helmet with some complex inner cushioning that's supposed to be optimized for preventing concussions and personalized to each player. Here's some example of some more metal parts. So it's a little bit of a mixture of aerospace and medical. Those are like the two industries that have the most use for it now, just because some of the technologies, well, I wouldn't say the most use, but like kind of the most like industrial, broadest adoption of 3D printed devices in the industry. So the first one's a part from a rocket engine. There's a couple different medical devices here where you can see that there's some complex geometries, and that helps with, those are all for bone. And so those complex geometries help with bone integration into the implant and stability of the implant then in healing. And then the last one here on the right is, I forget the technical, I'm gonna know the medical stuff so much more than I know the aerospace or automotive part of it, or it's maybe just industrial. Basically, it's a cooling chamber, and they're able to get it to be really small, and then also the complexity of the inner chambers for it for cooling is not possible to achieve it's only possible to achieve with 3D printing. So then what I said, really cool, the bioprinting stuff. So we're going to watch just a minute or two of this video on what they're doing with bioprinting.
There are currently hundreds of thousands of people on transplant lists, waiting for critical organs like kidneys, hearts, and livers that could save their lives. Unfortunately, there aren't nearly enough donor organs available to fill that demand. What if, instead of waiting, we could create brand new, customized organs from scratch? That's the idea behind bioprinting, a branch of regenerative medicine currently under development. We're not able to print complex organs just yet, but simpler tissues, including blood vessels and tubes responsible for nutrient and waste exchange, are already in our grasp. Bioprinting is a biological cousin of 3D printing, a technique that deposits layers of material on top of each other to construct a three-dimensional object, one slice at a time. Instead of starting with metal, plastic, or ceramic, a 3D printer for organs and tissues uses bioink, a printable material that contains living cells. The bulk of many bioinks are water-rich molecules called hydrogels. Mixed into those are millions of living cells, as well as various chemicals that encourage cells to communicate and grow.
Okay, so that's just a little bit on bioprinting too, and especially in the healthcare space, I think that's really new. Or it's going to be really exciting when that's possible. And there's a lot of really great work that's happening currently in that area. So then,
would you have to like buy it or something? Like say that they 3D printed a heart, would you like buy it, or would they just give it to you as like a medical bill or something?
Yeah, as far as it probably would be coordinated through the hospital and whoever was able to actually produce the heart, so probably wouldn't be available directly to people. I don't know what the, like, it would probably be similar to how it currently works for transplants. There's still, even though you're not buying something, there's a lot of costly parts of the process of getting a transplant from a donor to a human. And I think, yeah, however, with insurance and that sort of stuff, even though I work in the medical device space in the hospital space, the business side, or like the billing and all of that of hospitals, is crazy to me and very difficult to understand, both as a patient and as somebody kind of working in the space. But one I'm trying to understand better, because I think it is, by working in medical device space, it's a really important part to keep in mind. And if you want to help impact the patient, unfortunately, right now, healthcare is so expensive that that's having just as much of an impact on the patient as actually some of the solutions that are available. So I'm just going to close on kind of an overview of what you need to actually 3D print something. You start off with a digital model here on the left, and then there's software, but that's basically a software that you need to be able to create the digital model. But once you have that, then typically there's a slicing software that takes this digital CAD model, which is typically in the form of an STL file. And that slicing software is dependent on which printer you're using. That slicing software will will turn the part into information that the printer can then actually use to know how to print it. So how much material needs to be extruded, how fast does the nozzle need to move, in which directions, of course, then different if a laser is being used, and there's powder bed and all of that information. So there's lots of different sorts of software to then change the CAD model information into the information for the printer. And then the printer takes in that information and makes a 3D model. So really, when you creating the CAD model is a big part of it as well. But there's an awesome website called Thingiverse, which I'll share as well, where you can get lots of CAD models. And I do it all the time still too. If I need something, I'll like, oh, let's see if there's something on Thingiverse, and already gets. So if you ever have the opportunity to use a 3D printer, but you're not sure what you want to make, or you don't have the CAD skills maybe quite to make it, or don't want to spend the time on making something that maybe somebody else has made, then you can go there and get a CAD file from there. So this is my last slide. So just if anybody has any open questions, and I'll make sure to put that website in the chat as well.
Yeah, very interesting. Any questions from students or participants in this recording? Mr. Taya, like, it's just like breathtaking, seeing like that, the possibilities that are out there. And I think that we are amongst some of the most intelligent youth that have the mind space and the mind capacity to take this and run with it. for all the facilitators and all the adults online. I truly believe that our future is in good hands with these people who have been in our classes, who take this seriously and also have very good ideas about the world.
Yeah, I totally agree. And I'm amazed all the time with what people are coming up with. And I think when younger people are exposed to this, or even me noticing a difference as I've learned more about it, that it just opens up a different way of thinking about things and what's possible to make. And I think also too, eventually, like everybody will have a 3D printer in their house or have access to a 3D printer in some way too. And I mean, still even in our lab, it's just fun to like make toys on it now. Sometimes obviously we make really real important things as well, but just the ability to do that is pretty fun and cool.
Say, Coach L, do you want to come in?
Yes. If I can have folks turn on their camera really quickly, because it's so nice when you can see a face and understand who it is that you're impacting. Dr. Von Windheim, I'm hoping I'm saying that correctly, and forgive me if I butcher it again, but especially because you're on the campus of The Ohio State University. Thank you so much. Can we all give a round of applause, a virtual round of applause? Let's high five, all that good stuff in the chat. I'm excited about what we've put together, aren't you? Type a 1 in the chat if you're excited about this week, what's in store. We have an amazing team, an amazing ecosystem that we're developing. And if I may, instructors, may I share an announcement?
Please do.
Okay, folks. So this is for all of you. You should all be incredibly proud because you are a part of history. So we are officially the world's largest wearable tech hackathon that is being hosted. We did it. We did it. We have the numbers. I'm going to share some additional stats and all that other stuff. And of course, we have our focus on underrepresented talent. So what we have are a few challenges as well as we are getting loaded today. And so we have some of our folks from Discord that joined in because we had a challenge with YouTube. We're going to make sure that this is placed on YouTube later. But we have about 20% of our participants that have actually loaded into Discord. So we need to allow some time for those other folks to get loaded. So we're still going to do our opening ceremony and we're going to stream it. And so I'll tag some of our founder ambassadors to stream it from that opening ceremony channel in Discord if we can, but it's going to be this Zoom channel. But then we'll also give permissions for everybody in Discord just to go ahead and join here when we come back at noon. But I want to make sure that we allow our instructors that time so that they can close out this particular session. And instructors, do you mind if those that are here, if they participate in the word cloud, to give some insights? Do you want to do that, or do you want to wait? You tell me what works.
Well, no, like we can definitely upload the Jamboard because we want all of the notions and everyone's feeling about this. And before we do that, Ms. Elise, did you have? I thought you had something that you wanted to say.
Well, I just want to say thank you, Dr. Natalia. That was incredible. Here in Baltimore, I'm a teacher in Milford Mill Academy and teaching engineering. We have several 3D printers, and I look forward to, of course, using the Thingiverse and some of the other incredible information that you shared. It's got my wheels spinning, and I can't stop thinking of new things. I hope that everyone else is as enthusiastic, see, I can't even talk, and excited as I am about what's going on in STEM and STEAM right now. So thank you so much for sharing with us. I appreciate it. And thank you, Coach L, for giving us this opportunity.
I'm so excited. We got an amazing team. So you guys handled it so I can handle the stuff on the back end. I have media contacting me from New Orleans and Houston and Baltimore. So I'm going to be sharing, all that information during the opening ceremony. But before we do that, Dr. Von Windheim, do you want to share how folks can stay in touch with you or follow you on your journey?
Yeah, definitely. I will put my email in the chat too. I don't know if maybe there's a better place. Well, I guess if it's being recorded, I think the chat is recorded as well. So there is my email. And I just wanted to say as well, thank you so much for having me. It's really inspiring everything that you're doing as well. And I'm happy to contribute to it. So thank you all for hosting me.
And hopefully you'll hang with us throughout the week in Discord, you know, from time to time, if you, whenever your schedule avails. But it's amazing that we have all these amazing experts here. Then we also have our curriculum advisor, Dr. Nicholas Williams. You'll be hearing from him tomorrow in his technical workshop. I'm so excited about that. And we have a slew of other folks that we'll introduce later. But again, you're in the right place, people. So make sure, if you haven't already gotten into Discord, that you make sure that you access that, and we're going to walk you through it. And we understand that this is the first time for many. So our volunteers have been trained. They know to be patient. Our instructors know to be patient, and we're going to be very descriptive with everything. And as a matter of fact, we still have more volunteers that are actually syncing in and signing on today. We have so many people that want to help. So this is amazing. I'm just so grateful. So I'll turn it back over to our instructors for right now, and then I'll come back at noon.
Okay, so yes, to Ms. Lakeisha's point, we're going to provide you guys with that Discord link. We're also going to provide the Jamboard at this point in time. So Ms. Lisa, if you can get the Jamboard ready, I'm going to go ahead and provide the Discord link into the chat. And this is your opportunity to use those resources this week during the hackathon. All of the resources, all of the opportunities. We want you guys really to take advantage of this, because we have a lot of great minds in one space. So there is a lot of potential for ideas. And I'm still even going back to the one that Ash and Elise had about the LED, light for the shoes. That would be a game changer. So with that being said, we're going to give you guys the Jamboard here in a minute. I'm going to provide this link, and the instructions for the Jamboard is, please describe in one word, how today's class was, from our presenter, from our solar powered activity, to even your thought and creations about your inventions. Give us one word, and if you could, give us your initial as well, just so we know who's saying it. And we're just going to collect these words, almost like a word cloud. We're going to collect these words as we go forth, because we want to make sure that we're doing the right work, and we want to make sure that you guys are getting exactly what you need. So once we get the Jamboard to you, then we'll go ahead and have further instruction, but some things are coming to you your way. Miss Elise?
That's right. In just a moment, I'll be sharing the link, and we want to hear from you. I don't know about you, but this was such an incredible time today. And I don't know that I could have just one word, but if you could describe your feelings about it in at least that one word that expresses how you feel. And here is your Jamboard link. Did you get it? Let me see. Didn't seem to go up.
And that's okay. While you're getting that up, glad to see everybody here. For those that may have missed the announcement, we're doing just some quick feedback, and then we're going to invite everybody back here at noon, where I present the opening ceremony, and we'll go from there. But so happy that all of you are here and helping us to make history. And also thank you to University of Maryland, Baltimore County for being an amazing partner, for being so open-minded and working with us. Technically now this is our fourth year, even though we've done 3 years. This is our third year of doing classes, but we're so appreciative of you being forward-thinking and innovative to support us so that we can bring this to the world.
Okay, so guys, what I'm putting into the chat now is a Discord link.
Discord or Jamboard?
Well, I'm going to provide the Discord, and Miss Elise is going to provide. So Miss Elise provided the Jamboard up there. So if you guys click on that, you can go ahead and put your one-word description, and then I'll wait 1 minute, and then I'll put in the chat the Discord link, just so you guys can have the opportunity to research, explore, and research. I already said that, but yes.
Okay, so please don't forget to add your initials so that we have just a rough idea of where it's coming from, where these words are coming from, who's creating them. I put it up there so that you could see those who've already added to the Jamboard. So the question is, what is one word to describe your experience on day one of the hackathon? Oh, wonderful. Interested. Wonderful. Don't hesitate. Educative. Wow.
And this go for anyone in the room, you know, definitely add in the word from what you saw, or what you witnessed, what you observed.
And maybe some of you are hesitating because you don't know exactly what to do. If you go over to the left side, you'll see something that says sticky notes. It's 4 from the top in that area. A color pad will come up and you can select the color of your choice and then put a word on there. I'm going to say incredible. That's my word.
And Miss Elise, we can go ahead and stop the recording during this time.
Sure.
Thank you.
I no longer have access to the recording.